promised to tell you how to time a function. It's very easy with MATLAB. You time a function with the help of two other functions called tick and tock. Their names are supposed to sound like a clock ticking. You know, tick tock. Tell you what, go rent an old horror movie. They have lots of tick-tocking clocks in them. Anyway, tick and tock work more like a stopwatch than a clock. Tick starts the stopwatch, tock stops it. Well, let's time something. Let's time sum adding up the first 1,000 positive numbers. Well, I thought it would never get done. That took what? A little over 1,000th of a second. Let's give it more work. There are a million numbers. That took a whole 100th of a second. Okay, time to really put it to work. Let's give it 100 million numbers. 1 second. These computers are pretty fast. But let's run this much slower function instead. It's one that I've got over here called no pre-alloc. We'll find out what that strange name means in a minute. And let's put this command window right underneath the editor down here. And I'll bring it up a little closer. And now that I've got things arranged to my liking, let's have a look at this function. What it does is use explicit looping and these nested for loops to compute a good old-fashioned multiplication table and put it in A. We're going to calculate 25 million of these numbers because we got n equals 5,000, so 5,000 times 5,000, that's 25 million. So we better get going. Well, okay, yeah, this is taking a long time, so sorry about that. It's kind of boring. Tell you what, maybe this is a good time for a joke. All right, did you hear about the guy they asked how he felt about death? He says, you know, I'm not really afraid of dying. I just want to die peacefully in my sleep like my grandfather, instead of screaming in terror like his passengers. Okay, as the laughter dies down, the function still seems to be working away. Here's one of these times where you start wondering, okay, 46.86 seconds. That's a pretty long time, but you know, we did a lot of work there. 25 million calculations. Yeah, we did a lot of work here, but on a modern computer, 25 million calculations should go a lot faster than that. Here's a faster version of the same function called pre-alloc with just a single extra line added right here. Here we've created a matrix A by calling the function zeros and made it a 5,000 by 5,000 matrix. How can this help? We're still going to do the same 25 million calculations, and then all those zeros will be written over. It seems like we're wasting time, and we're going to make an already long function take even longer. And I don't have another joke ready. But let's get comfortable and start it running. Wow! That's a little better. 0.596 seconds. That's how many times faster? Let's calculate that. 78 times faster. How can this be? Well, in the no pre-alloc version, MATLAB had no idea how large the matrix A is going to eventually become. So every time we added a new row, it had to find another place in the memory and copy the entire contents of the current array into the new location before it could add the next element. Finding a place in memory and reserving it for a variable is called memory allocation. And it had to do memory allocation over and over and over. While memory allocation is usually a minor part of the time required for a program to run, If we have to do it thousands of times, it can take a noticeable amount of extra time. That's bad news. But the good news is that most of the time this extra time is completely unnecessary. In this example, we knew before the loop started how large the matrix A needed to be. So in the second version, we initialized A to the right size before starting to compute its elements. That avoided all the time MATLAB spent on memory allocation and reallocation using the first version. Allocating memory before you need it is called pre-allocation. Kind of an obvious name, I guess. The way you do it is call a function. We use the function zeros, whose arguments tell it the dimensions of the array to allocate. It'll allocate the space and put zeros into every element. There's another function like it named ones. Let's just say I won't insult your intelligence by telling you what that function does. But at the risk of a tiny insult, I'll give you this advice. Pre-allocate every time you use a large array whose dimensions you know. And guess what? MATLAB gives you that same advice. It's easy to miss. Let's look back at this no pre-allocate function. The advice is right there. If you look very closely, you'll see a little red squiggle right here under this A. And if you hover the mouse over the A, you see a little hint pop up. The first one says the value assigned to variable A might be unused. Okay. The second one says the variable A appears to change size on every loop iteration. Consider pre-allocating for speed. The textbook has a more detailed explanation about why this version without pre-allocation is so much slower than the other version. And it gives you a simple trick for speeding things up when you can't pre-allocate by simply changing the order in which you nest your loops. Well, that's about it for Lesson 6. But we'll leave you with this parting thought. Loops, whether they're for loops or while loops, whether they're explicit loops or implicit loops, are the programming constructs that let us exploit the amazing power of computer hardware. The power of that hardware is measured in billions or trillions of memory cells and billions or trillions of instructions per second. But without loops in the software directing the circuits in the hardware to iterate repeatedly through the paltry few commands that we humans can type into it, these big impressive numbers would mean nothing. The amazing things that computers do, like searching through 30 trillion web pages, answering spoken questions in multiple languages, pulling your car out of a skid on a slick road, landing a rocket on Mars, calling the one phone you want out of 7 billion, or even just playing this lesson for you, would just not be possible without loops. Well, to be more precise, they might be possible, but only if you had a few billion years to get them done. If you don't want to wait that long, iteration's the only way to go. It's simple. If you look into every world-changing effect that computers have had in the last half century, you'll find a loop down there somewhere inside driving it.